For today's lesson, we'll be looking at what to expect for your paper one questions. So to determine the inverse, you would need to solve your x and your y, and after doing that, all you have to do is then one the subject of formula. For example, say that our original equation, let's say y is equals to 2x plus 3. For you to get the inverse, you would start the y equal x, and you would x. Y is subject to formula. So y is equals to x minus 3 over 3 is the inverse of y is equals to 2x plus 3. Now, for your function, your original function and its inverse, they are actually going to be symmetrical with regard to the line y is equals to x. So this means that for every point AB that exists on F, we will have a point BA that exists on the inverse. The x-intercept of our original function would be then the y-intercept of our inverse. The y-intercept of our original function would then be the x-intercept of our inverse. And for the graph of the original and the inverse, they will intersect each other at the y is equals to x point, where y is equals to x, all the intersects will be then the same point. Now, the problem with our inverse, especially our parabola, is that when we have the inverse, the function is no longer considered a function. So we define a function as something that's going to then have one x value and it will give you one y value. Now, if we look at this graph over here, if I were to inverse it, I would get a line that looks like this because it is a reflection of that thing. Now, the problem with this graph is that with one x value, we get two y values, which is then not a function. So what we need to do is that we need to then restrict the original so that we can restrict the function so that the function can become a function. So the graph can become a function. So if we had restricted it to just this, then we would just have this as our inverse, and that is a function, and it would become a reflection about the y is equals to x. So things that we also need to be aware of is that the domain of our function will then become the range, and the range of our function will become the domain for our inverse. We can also have other reflections other than the reflection about the y is equals to x line. We can have a reflection about the x-axis where your y values should be replaced with a negative y value. We can have a reflection about the y-axis where your x values are replaced with a negative value, and we can have the reflection about the y-x, which is then your inverse where you swap your x and your y. To get more practice of your functions in inverse, please head on to the past paper recordings to see how this is